We're asked to find dy dx. So we want to take a derivative of this equation with respect to x to make that happen. Just remember dy dx, we often use y prime for shorthand notation for that. Okay, so I'm taking derivative of each term. So I'm doing d dx of each term. So the derivative of this term with respect to x is just 1, right? Because the power comes down and multiplies and gets reduced by 1 for the derivative. Now the derivative of this term is going to be a little tricky. We need the chain rule. The outermost function is tangent, okay? So the derivative of tangent is secant, and everything inside stays the same. Sorry, secant squared. Whoops, sorry about that. The derivative of tangent is secant squared. And now I need to take a derivative of the innermost function. So I'm just focusing on this and forgetting about that tangent, the outermost function. So when I try to take a derivative of x squared y, those are two things multiplying to each other. So in our head we should be thinking, okay, product rule. So I'm going to use parentheses because the product rule has two terms in it, and I don't want to just multiply to the first term with product rule. So the product rule says you take a derivative of the first term, the first item, first number, in this case the first variable, and then you keep the second variable the same. So the derivative of x squared with respect to x is 2x, and then we keep y the same. And then it's plus the first number kept the same times the derivative of the second. So the derivative of y with respect to x is y prime. It's not 1, okay? Because we're taking a derivative with respect to x, not with respect to y. If we're doing d dy, then this would be 1. But since this is d dx, we don't know what y is as a function of x. So we have to say the derivative is just y prime. Okay, now we're done taking a derivative, but our goal is to solve for dy dx, so I need to get y prime by itself. So the first thing I'll do is distribute the secant squared x squared y term to both things. Okay, so when I do that, I'm going to get 2xy times secant squared x squared y. It's like you distribute a 2, when a 2 is in front of a parentheses, except we're distributing a huge thing. Distributing this whole thing to both terms. So when I distribute it over here, I get x squared y prime. And my motivation for using the distributive property here is because I'm trying to get y prime by itself. I'm trying to get y out of the parentheses. Okay, so I got y out of the parentheses. I'm trying to get y prime by itself, so let's get rid of this term. I'll subtract 2xy secant squared x squared y from both sides. It's a mouthful. Okay, and I've got this left over. Okay, and so the last step to get y prime by itself, I need the x squared and the secant squared x squared y to go. So I'm going to divide x squared secant squared x squared y from both sides. Divide it from that side, so I'm going to divide it from this side. Okay, so that makes this cancel out and this cancel out, and we got y prime by itself. So I'm going to use some computer functions to help me so I don't have to copy that all down again. This is dy dx. We solve for y prime finally. Okay, nothing you can really simplify here, so that's as good as it's going to get. Okay, well, I thought this was okay. The book does do a little bit of rewriting for this type of problem. So look, this entire numerator is being divided by this denominator, so we can break it up in two separate fractions. Okay, it's yucky, but it's something we've done before in math. If you have 1 minus x over 2, that's the same thing as 1 half minus x over 2, right? You can break up that denominator to both terms. That's all I'm doing here. So this is 2x y secant squared x squared y all over x squared secant squared x squared y. Okay, so secant squared and secant squared cancel out. It makes 1 when you divide them. And you got x divided by x squared, so we'll lose an x down here, we'll lose the x up here. And then they rewrote this in terms of cosine. Secant is 1 over cosine, right? So if you got 1 over cosine, that's the same thing as cosine in the numerator. So cosine squared x squared y all over x squared. I didn't move that x squared around, so that stays on bottom. And in this term, after everything's canceled out, I get minus 2y over x. So that's the type of answer the book has. Which one is more simplified? I don't know. I guess this one has one less trig function, so I guess the book's answer does look a bit better, but they're both algebraically equivalent.